Anyone who spends even a moderate amount of time online has likely come across social media posts falsely claiming that COVID-19 vaccines are harmful to human health. Among the most widely debunked claims is that vaccines developed with messenger RNA technology can cause cancer because they contain monkey virus DNA. Such claims were even repeated during a U.S. congressional hearing on vaccine injuries last year. But North American and European health authorities have stressed that there is no proof that COVID vaccines cause cancer or that mRNA vaccines can alter human DNA in any way. Joining us now to discuss the facts and myths about mRNA vaccines is Dr. Abhishek Raut, Medical Director at Appletree Medical Group. Dr. Raut, thank you for being back with us again.
Great to be here.
We've seen some pretty wild conspiracies about mRNA vaccines, everything from monkey DNA to these vaccines causing cancer. As a medical professional, have you encountered these conspiracies in real time? And if so, how do you deal with that?
Yeah, so unfortunately, I have encountered that, and many of my colleagues have as well. I think it's very disheartening to witness that spread of misinformation, especially in a digital landscape, which is what we're seeing these days. We have several studies that have found that people who were exposed to vaccine-related information on social media were more likely to be misinformed and vaccine hesitant. And we've had separate studies as well, some from the UK, that showed that 2/5 of people who encountered negative messages about vaccination on social media platforms. So we do see a lot of negativity and a lot of theories there. And a lot of addressing that is about education and listening with empathy.
For those who maybe don't know how mRNA vaccines work, can you explain to us how exactly they can protect people from disease?
Well, the mRNA vaccine is definitely a revolutionary approach to delivering a vaccination. So the injection will have mRNA synthetic fragments, which gives our cells instructions on creating a fragment of the virus's protein. So that's the spike protein many of us have heard about. So once inside our cell, our cellular mechanisms will create this fragment of spike protein, and then our immune system will then respond to that fragment. And so the body then generates antibodies and activates immune cells. So it's literally like having an artificial or simulated encounter with the virus and then mounting a robust defense against it.
Now, beyond COVID-19, what else are or have mRNA vaccines been used for?
I think there's a lot of potential for mRNA vaccines. When we're looking at it from a utility perspective in immunotherapy, cancer treatments certainly jumps to mind, and that's something that we've been exploring for quite some time. There's also a lot of hope for diseases such as influenza, Zika virus, and cytomegalovirus, which we could do similarly as well. But of course, there's a lot of challenges associated with that. So further research is still in the works.
So, why do you think there is such a dramatic hesitancy to mRNA vaccines when compared to other more conventional vaccines?
Well, if we look at the first vaccines, which were the cowpox vaccines, that was almost 200 years ago. So we do have a significant history with vaccines, especially the conventional one. The mRNA is very new. It's a novel technology, and of course, with anything novel in the medical field, there is a little bit of apprehension, and it also depicts a departure that we're going to have from traditional vaccine platforms as well. So what we're seeing is basically a lot of this hesitancy is because the mRNA vaccine is quite novel. And then once we have it for a long period of time, I think we're going to see that hesitancy disappear as well.
Now, you mentioned a few things, but are there exciting developments for mRNA vaccines that you are particularly looking forward to?
Yes, so I think the biggest excitement of mRNA vaccines for myself is really stemming from a broader use for it. So we're actually looking at it, or at least researchers are looking at it in lipid nanoparticle formulation. So if that works out well, mRNA is going to be very helpful in even keeping our cholesterol levels down as well, which is going to affect quite a bit of us. I briefly touched on cancer immunotherapy. That's a very exciting field. To directly help people with cancer by using mRNA technology there.
Now, as a medical professional, what are some of the best ways that we can collectively ensure that Canadians are given the facts about vaccines? We have about 20 seconds.
I think the best thing to do here is to make sure we have an open dialogue, really address concerns empathetically, and provide just an accessible forum for people to express their concerns, express the conspiracy theories, and then we can use education and evidence-based learning to really bring down that hesitancy.
Thank you so much for your time today.